All right. And hey, Rohan, welcome to the session. All right. So, so I think John is not around yet. Okay, let's go ahead. So, John was suggesting that there will be 5 people in the session. There'll be Brian, and then there'll be 2 more people. Okay, so I'm going to share my screen now. All right, that's my terminal. Okay. All right. And let me hide the notes. Good. All right. All right. So, so before we start the discussion, do you have any questions, or should we go ahead now? All right. So let's jump in. So first of all, welcome to Introduction to Big Data and Big Data with Hadoop and Spark. This is not our typical introductory session. This is going to be a little shorter than that, because our typical introduction to big data with Hadoop and Spark is around 3 hours, and this is going to be close to 45 minutes. All right. So, so we are hoping it to be about around 45 minutes, but we'll keep the whole session in a discussion format. That way, it will be bearable to everybody. Okay, so is my screen visible to everyone? Are you able to see my screen? Great, great. All right. And let me see if just a second. I just trying to see if my audio is good. Yes, audio should be good. All right. So welcome to the introduction of big data with Hadoop and Spark. And the agenda today is number one, we will talk about who we are and why are we doing this. Second, understanding the basics of big data, and then the use cases of big data, and the curriculum for the complete entire course. Then the discussion on what is CloudxLab, the lab around which the course and the learning sessions are built. We will talk about that afterwards. All right. So who we are? So we are from we are from a company who provides learning experience. And the way we provide learning experience is by the way of 2 products. One is called No Big Data, other is called CloudxLab. At No Big Data, we provide expert instructors, and the approach is very hands-on because it's complemented with a real-life lab. And then we have lifetime access to the LMS where we can keep all the content, recordings, assignment, quizzes, and project work. Then project is generally based on a real scenario. And after the course, we do 2 projects in this, and they are based on real life scenario. We provide 24/7 support to our learners via email. And we have a group of all the students of our organization. We formed that Yahoo group. Okay, sorry, now it's Facebook group. So we have a Facebook group where we add all the alumni so that they can talk about something, talk about big data, as well as they keep connected with us, and we keep on sending them all kind of information. All right. So who am I? All right. So it's important for you to know that that I have been into the field for quite some time. So I did my graduation in 2002 from IIT Roorkee. Afterwards, for 4 years, around 3.5 years, I worked with a very interesting company called DE Shaw. DE Shaw is a New York-based company, and we built the big data systems even before the term was coined. Even before the term was coined. Now, so at DE Shaw, we had a cluster of 10,000 nodes. So what does it mean? So we basically were able to handle terabytes and petabytes of data when the world was still haggling with gigabytes of data. So that was something I learned in 2002, and that's around 14 years ago. So we built our own systems, which were on similar lines like Spark and Hadoop, but not as sophisticated as Spark and Hadoop. So we built those kind of systems in around 10, 15 years ago. Afterwards, I started a company called Tbits Global, which was built around the idea of providing the enterprise grade document management system. So this document management system was able to handle humongous data in a variety of formats. Then in 2012, I joined a company called InMobi as a data scientist, where I churned data around 200 terabyte. 200 terabyte is humongous data. And we were able to do it only because we had this big cluster which we had built, which has more than 1,000 nodes. So we were able to churn that kind of data on this large scale. So that's what I did at InMobi. We built the recommender system. Afterwards, I worked with Amazon's detail page team, where I built a platform to optimize images, the image that you see on Amazon's detail page to the bigger image that you see of the product on the left top corner. Okay, the product image was one of the projects which I did. Along with that, I built the mobile page for their mobile page for the detail page of Amazon. Afterwards, I started No Big Data, realizing that the industry does not have great set of instructors. So I looked around, tried to interview various kinds of instructors who were very popular. And what I found was something very interesting. I found that most of the instructors did not have any product development experience. Neither they had actually worked on real life use cases, nor they had the technical expertise. And that's what was my realization, that there is a huge scope. There's a huge scope, something which I've learned in my career. I can I can teach that in a better way. And that's why we started No Big Data. All right, because we had this great flexibility of building the course. And since then, the classes have become, for No Big Data, the courses have become very popular and kind of industry standard. Uh, and and for our students at No Big Data, we needed to give a real environment. The way I was given a real environment at Amazon, they provided me an entire cluster so that I could build an experiment on a big data system. Similar way, when I started No Big Data and I realized that there is no cluster around, and to set up big data environment for individual takes 15 plus days, and sometimes it's not possible at all. Therefore, we started CloudxLab, and since then it has been a very wonderful journey. I have If you look around at Quora and look around at Facebook, you will find lots of great feedback about us. So that's about CloudxLab and No Big Data. And these two things we are going to talk after a while. So we talked about No Big Data, that we provide great trainings, and No Big Data we provide lab. These are the two things that we are working right now. All right. In the meantime, from time to time, when people get stuck at some big data projects, they generally come to us and give the consulting assignments. Okay. So once in a while, we work on consulting assignments, but that's rare because we already have hands full. All right. So let's start with the simple question: what is big data? What is it that you understand by big data? Yes. So what's your definition? Let me remove the slide. Okay. I'm just going to remove this slide. So what is your definition of big data? It's important for us to communicate continuously so that I'm able to keep my pace. Otherwise, I'll just start running. And so I would love to get your point of view, Samambo and Subi
Yeah.
and Josephine. So what do you understand by big data before we jump into my definition?
We, according to the some few researches we've done, we understand that big data is, can be a lot of data, both structured and unstructured.
Correct.
It's mainly defined by 3 or 4 V's, which is volume, velocity. So the terms have gotten a little bit of my head.
Wonderful. Wonderful.
Yeah.
Wonderful answer. All right. So yes. So big data is essentially the data of huge size. Okay. Data of huge size. Thank you, Asambo. That was a good answer. All right. Anybody else wants to answer before I jump into my definition? All right. All right. So you keep answering, interacting all the time on the chat so that the session remains lively for you. And I enjoy answering your questions. Every question is very important for me. And there is no such thing as bad question. Okay. So feel free to ask as many questions as possible. And the reason why people like my sessions is because they want answers. They want answers to their doubts. Otherwise, there's a lot of content around internet which has a lot of big data information, but the problem is that people don't get the answers, and that's the reason why people come to my classes mostly. So I would love to see your more and more questions, and that's the only way to learn. All right, that's the only way to learn. And the chances are, if you have a question, the chances are others in the same class would be having the same question. It's just that they are not asking. So when you're asking a question, you are actually doing a favor for others as well. All right. So because me being the other side of the table, sometimes I think that I have explained something nicely, but it doesn't work that way. Sometimes I'm not able to explain a lot of things. I generally just keep assuming. Therefore, it's very important for all of us to keep asking questions. There's no such question. There's no such question as dumb question. There's all the questions are great. They have a reason. There's a reason for asking a question. Right? So keep asking the question, and that's the only way to learn. All right, there's a basic philosophy around my classes. One is practice, other is questions. Now, in the first class, we don't have too much to practice because it's mostly theoretical. From second session onwards, everything becomes entirely practice oriented. So I ask all the people in my class to log into this the lab simultaneously, and in case somebody gets stuck, I help them to be up and running by giving them the screen share control and see the screen of the candidate, and then all of the candidates get up and running, and whatever I do, I generally ask in the class to practice along. Okay, so that's the model which we follow: questions, practice, and then theory. All right. So so uh, okay so now coming back to big data is, it's simply data of very big size that you cannot process with usual tools. So when somebody says that data of very big size, the next question that comes to your mind is, what kind of size are we talking? So your answer is that you cannot process with usual tools. Now you will have the further question, what kind of usual tools? The answer is the tools that are not distributed in nature, meaning your usual file system like C colon, D colon on your machine, as well as the usual database, which run on a single computer. So that you, so data of very big size that you cannot process with your usual tools, and you need distributed architecture. The data could be structured or unstructured. All right. So that's big data. And there are three, we'll talk about 3 V's later. So the next question which people have is, what does it mean by structured and unstructured? In structured data, the strictly structured data is something which you have been using all the time. For example, in the database, where you know exactly what kind of columns your table has, as well as what are the data types of those columns. That's structured data. On the other end, you have unstructured data. In unstructured data, you don't know the format of your data, as in you don't know how it's not readily available that where does a column start and where does another column where does a column ends and another column starts. So you do not know the fields or the columns in your data. That's unstructured. Semi-structured is where you know that what are the fields, but you do not know what are the data types of the field. For example, CSV file. CSV file contains columns separated by comma. You know what's there in the column, but you do not know whether the column is string, date time, or a column is Boolean flag. Okay, so therefore, that CSV or XML kind of data is known as semi-structured. Unstructured means there is the data is does not, we do not know right now about the fields in the data. All right, next question you might be having in the mind is, we talked about distributed computing. What does it mean to us? What does it mean by distributed computing? Distributed computing means group of networked computers interacting with each other to achieve a common goal. Okay, let me simplify. You take few computers, connect them into the network, and use these all computers to solve a common goal. Distributed computing and parallel computing are similar terms. In parallel computing, you have a single computer with many processors, and you're using many processors. Okay, so interestingly, both distributed as well as parallel are very similar in nature, because the idea at both the places is to distribute the logic in parallel computing as well as distributed computing. All right. Any questions at this point? We talked about what is big data. We talked about what does it mean by structured, unstructured, semi-structured. And we also talked about what does it mean by distributed computing. No questions?
Hello.
Yes.
So you mentioned that the processing is done by network computers, which
Right.
can be a number of them. Is there a limitation in terms of resources? How much a node should have?
Mm, okay. On the number of nodes.
Yes.
So when we say distributed computing, even if we are using two computers connected in the network, that's known as distributed computing. And more than one is what is known as distributed computing. So basically, the limitation comes from the tools that we are going to use for distributed computing, because it's difficult and hard problem to distribute your logic. Okay, imagine printing numbers from 1 to 100, right? Then you will have to give some computer some assignment that, okay, you print 1 to 10, another one will print 10 to 15, and next one 15 to 45, and so on. You will divide that work. So distributed computing is tough. It's difficult to convert a normal problem into distributed computing. And that's why we need frameworks. And those frameworks come in many shapes. We start with Hadoop, Spark, Hive, Pig, those frameworks that make distribution possible. As well as there are platforms like Hadoop and there MongoDB, Cassandra. All of these are essentially you helping us converting our problem into a distributed problem, meaning these tools are helping us solve our big data problems. Now, these tools might have the limitation, but distributed computing does not enforce any limitation on number of nodes. All right? Did I make sense to you?
Yes.
All right, wonderful, wonderful, great question. All right, any other question at this point?
No.
Great. All right. Now, there are three characteristics of big data that are very important. And these three characteristics are the reason why certain data we call as big data. All right. Velocity, volume, velocity, and variety. Okay. So certain data would become big data because of volume or velocity or variety. Either one of these or more than one of these. Okay, I'll take example. So this is very important to understand that all the tools that we study in this course, they would try to address either volume, velocity, variety, or two of them or all of them. Okay, so let's see what does it mean by volume. Let's say your assignment is to store 100 terabyte data. Now, 100 terabyte data is huge. You don't have a single computer provide a single hard disk providing you that kind of storage, right? Now, if you think about Gmails and Facebooks storing the videos and the emails, well, how would they be storing that? And that kind of problem, that kind of problem of storing such humongous data is the volume aspect of data. So if volume, by virtue of volume, you are not able to handle a particular business problem, then you call that business problem as big data problem because of volume. Okay, and in such cases, you generally go with the solutions like HDFS, HBase, Tachyon, or AWS. Now, the second characteristic of big data is velocity. Okay, the second characteristic of big data is velocity. The problem involving handling of data, which is coming at fast pace. Okay, the data in motion. Now, if you imagine how would you handle situations like Facebook, because the whole world is checking Facebook every second. Now, number of requests are in billions per second. How do you handle such kind of circumstance? Right? So such kind of problems become big data problems because of number of requests or the speed at which the data is coming. That's velocity. The third one is variety. This is a very interesting part to understand. Right? Also, to handle the velocity, you generally use Storm, Spark, and HBase. We'll talk about these tools as we go forward. The third one is variety. Okay, variety is also known as complexity of data. It is also known as complexity of data. Now, imagine that I have to plan my trip from here till Uganda. And there is a map. The map size would be hardly 10 gigabytes. 10 gigabytes is not that big a number. Now, we have a map, and the size of the map is, say, 10 gigabyte, and we are not in hurry I mean, we have, we do not have to solve it per second for millions of users. Now, to find a path from here till Uganda, we have to evaluate so many permutations and combinations. We will have to evaluate so many possibilities, and we'll have to handle the complex structure of data in the form of map, right? So such kind of problems become big data problems by virtue of variety or complexity. Other examples could be, let's say there is a social graph, and I have to find that how am I connected to Besambo, right? How am I connected to Semambo? Not Besambo, I'm sorry, Semambo. How am I connected to Semambo? And then, so for that, the whole graph has to be evaluated. Or let's say you have got a billion emails. You want to figure out whether an email is important or not. So these problems involve complexity. These problems involve complexities, and therefore, because of such complexity or variety of data, your problem could become a big data problem. Your problem it could become impossible to solve using existing tools. And that's why we call those problems as big data problems as well. So we will talk about MLlib, GraphX, and also Mahout briefly to address variety part of data. All right. So here's a question for all. Okay. So anyway, before I ask you a question, do you have a question for me here?
Hello.
Yes.
So you mentioned in variety, you mentioned the various kinds of structures.
Right.
And you gave an example of social graphs.
Right.
I'm kind of new to social graphs. Is there a way you can explain that to us so we get to understand?
Right. Right. So imagine that, okay, so if you think about, say, Facebook or LinkedIn, right? So people are connected to each other. I'm most likely connected to you maybe in 2 steps or 3 steps. So, but we don't know yet. Let's say you are given this whole list of people, like who is connected to who has which friends, and so on. Now, imagine that you are given this in 2-column format. First column is a person's name, ID. Second column is the ID of the friend. Now, given this 2-column data, let's say you have to find out who is the person who is highly connected, or you have to find out how 2 people are connected, how many friends are there in between the two, any two arbitrary persons. And let's say the other, there are hundreds of problems associated with this kind of social graph. This is social graph, meaning there are many representations for many mathematical representations to represent a graph. Right now, I have just given you one form. It's called adjacency matrix. Anyway, keeping that aside, so we have information that who is connected to who, okay, in the form of, let's say, two columns. First column, the source, and the second column, the destiny. Now, given this kind of data, there are many things that could be addressed. We can address that out of this, which profiles are fake, right? Based on maybe they have created these arbitrary friend networks and kind of isolated networks. Similarly, based on this, we could also give recommendations that, hey, looks like you are in the same circle as Rohan, or you are in the similar circle as Semambo. Therefore, you can send a friend request to Semambo because you looks like you both have many common friends. And these kind of properties of social graph are very valuable for various businesses. All right. And so this is called a social graph, the graph of the social structure, as well as sometimes the graph has many more complexities. Say I have my parents as well in the social graph. That's and we mark this relationship. Similarly, I have a colleague who I have been working for quite some time. We mark this relationship. So social graph could become extremely complex based on what we are trying to achieve. Did I make sense to you?
Yeah, yes.
All right, great questions. And all right, now my turn to ask question. All right, so we learned what is basics of big data, and we also know that a petabyte is a huge data. Petabyte is 1024 terabytes. The question to you is 1 petabyte big data? If you have to count just vowels in 1 petabyte data every day, just count how many vowels are there. That's all. Or more, even simpler than that, are total number of vowels odd or even, right? If you just have to do that. Now, question is, can you do that every day? Can you get number of vowels in 1 petabyte data every day? That's my question. Or in other words, if you have to do this every day, can you achieve it using a single computer, or you will need a distributed system?
In terms of volume, but
Yes.
we need distributed processing or something.
That's right. That's right. Because here, it's not a complexity of problem. It's not the variety of the problem. It is basically a very simple analysis of the data, very simple analysis in which you just have to read data from left to right. That's all. But in such kind of problems, the main thing that becomes bottleneck is the reading speed of a computer. Therefore, you will have to store this kind of data on many computers parallelly, let all computers count the vowels at the same time so that you can achieve it in a single day. Make sense to you? So yes, 1 petabyte is big data because most of the existing systems cannot handle it, and therefore you will need to build a big data environment for this kind of problem. All right. Did it make sense to you?
Yes.
Great, great. So keep asking question on the chat so that I can, so that you don't forget the question. All right. Next is this the standard graph which shows that in 2002 the digital age began, as in the data started exploding, data started accumulating at an exponential rate. And the data we are talking about, not the data in the paper books, which is analog. We're talking about the digital data in the form of zeros and ones. Now, why did that happen? Why did it started becoming so huge? Why did we started accumulating so much of data? The simple answer is devices and the networks. On one hand, the devices, the hardware, became cheaper, faster, and smaller. On the other hand, the connectivity between the devices or the people became better and faster and everywhere. And these two reasons are the reasons why the data started exploding. The data started increasing exponentially. Because on one hand, you can look at the smartphone as a device that generates data. You take pictures, you send messages, you record voice, you record videos, you make calls, and so on. The smartphone is basically your data generation device. And not only that, if you talk to anybody, any of your friends who is into hardware industry, they'll tell you that all the hardware companies have their KPI, the key performance indicator, the objectives of their organizations are to make the devices cheaper, faster, and smaller. So they have been successful in doing that on one hand, and on the other hand, connectivity is omnipresent. It's everywhere, and there are many forms like Bluetooth, Wi-Fi, and NFC, and normal optical fibers, and 3G, 4G, 2G, and so on. So connectivity and the devices are the reasons why there is so much data. And of course, once these two things have been in place, new ways of sharing information in the form of various online services have come up, the social networks. Now, so we talked about problems. The question is, what do we do with this data? Is it useful, or should we ignore it, or can we utilize it? So as you see in the screen that there's a person walking, and he's essentially generating a lot of data. He's wearing a band, he's maybe in the shoes as well, and there are cameras on the road which are monitoring monitoring the roads and so on. So question is, what's the point? Who are the users, the customers of this humongous data being stored? The first and the most prominent ones are the e-commerce and web. So they were the first one to basically harvest humongous data. Example is recommendation engine. Amazon's maximum sales happen because of great recommendations. The email that they used to send about new products or updates about products were marked as spam, while when they started giving recommendations instead of usual emails, suddenly their sales became higher and nobody marked their emails as spam. And their sales are governed highly by the recommendations. You see on their website, you may also like this, customers who bought this also bought this, and people who after buying this, they bought this, and so on. So these recommendation engines become a huge friend of the buyer, and they are not biased. So basically, recommendation engine in form of e-commerce, in the form of, let's say people are watching movies and Netflix is giving the recommendation based on their past history that because you like these movies, you may also like that movie. And that has become their mantra of success. All right. Second is the sentiment analysis. Okay. Second is the sentiment analysis. In the sentiment analysis of a product, you basically, instead of conducting surveys, you study the social graph. You study the social data on the social networks or the other channels. So you try to figure out whether people are talking negative or positive about my product, service, or the brand by using Twitter, Facebook, or any other private means of network. So there are many more interesting things that have been done there. Now, here, when you do sentiment analysis, it's a problem of volume plus velocity. Sometimes you want to see at the end of day what has been the progress. Sometimes you want the response within seconds. So when you want response within seconds, the problem becomes that of velocity. And when you want the response within a day, that's a volume problem largely. Okay, so basically you use the humongous data to figure out whether people are really liking our product and how is the distribution uh, across the geography, across the gender, across the age group, and so on. So that's called sentiment analysis. So we take up a project on sentiment analysis as part of this course, as well as we take up one example problem of recommendation engine. Third is load prediction. Okay, so every year Amazon conducts the load prediction before Christmas. Like Christmas is coming now. By now, the whole Amazon would be kind of on their toes, uh, trying to basically stress test their systems. Okay, so load prediction is a very important aspect, and the reason why companies like Amazon or they basically exist because they survived while others failed on the load. Okay, so that's that. Basically, the reason why they set up AWS was to the reason why they set up AWS was because they were shut down on one of the Christmas or Black Friday, and because of too much of load. Afterwards, Jeff Bezos, the CEO of Amazon, went ahead and bought all kinds of hardware, decided that will not let it happen next year. And that's where the whole engineering behind handling load, handling data, handling the load, handling the prediction of the load came into play. So while doing the load prediction, there are many factors to be considered, and that requires a good amount of engineering. The fourth one is A/B testing. This is a very interesting aspect which not many companies are able to execute very well. A/B testing comes from the background on medicines. You give a medicine to you generally split the patients into two parts, those who are given medicine and those who are not, and then you observe whether the medicine is doing any job or not. Similarly, in most of these companies, and I'm talking about my personal experiences, so I'm again talking about Amazon. At Amazon, the color of the buy now button is decided based on A/B testing. Some people said orange, some people said red, and some people said blue. So what we did was we ran all three buttons for 2% of the crowd, 2% of the end users. We showed only the blue button in the buy now. For next 2%, we showed orange, and for rest of it, we left the button as such, whatever it was. And what we found was the orange colored button of buy now had the best possible sales. The best possible sales came from orange button. Now, because Amazon has good enough data and they were able to build this robust A/B testing platform, they were able to come up with the definition of features because of the data, not because of some designer or some UI expert giving the suggestion. They based their whole hypothesis on data, not on somebody's ideas. So this is something great. I learned that lots of features, lots of product features could be improved if companies had enough data as well as a great A/B testing platform. And that's what, so for example, the feature which I built, the mobile page that I built for Amazon, it it was basically tested again and again in the production for a very small crowd. And when it started performing well, then they started increasing the total crowd on this feature, though those who will see the number of users that will see my detail page which I designed for Amazon. And finally, after I left Amazon, after 1 year of my last date at Amazon, my detail page bubbled up. And that's what is being used in India right now. So this is the power of A/B testing. This is the power of the data. This is the power of having big data in place on A/B testing. Next is the IoT. IoT devices are going to be the biggest revolution. So what is IoT? It's called Internet of Things. Essentially, hardware, essentially sensors placed in almost everything, whether chairs, shoes, or walls, or fans, or let's say in the ground for monitoring the crops. So sensors and the devices, the physical world where we gather all the data and then operate on that. So IoT is a great customer of big data because they build, I mean, in IoT, the idea is to gather data, but the IoT does not provide the data platform as such. Data platform is the big data platforms. Okay, so IoT is nothing but lots of devices, because these days the devices have become cheap, everywhere connected. So it's possible to gather data. And so IoT is the biggest consumer of big data. Next is telecom. In telecom, almost everything is of huge scale. Even counting how many customers are coming per second or how many calls they're making per second is a tough problem for them. And therefore, telecoms are the default users of big data. Next is the government for detecting fraud, detecting cybersecurity, and doing justice. So in all these domains or the verticals, big data is already being used. Next is healthcare and life sciences. Again, just like telecom, everything in healthcare and life sciences is of humongous size and the complexity. Complexity because DNA testing, the figuring out the sequence of DNA which matches with certain other DNA to figure out the sequences, it's inherently complex. Inherently complex. Therefore, healthcare and life sciences are also big users of big data. There are many tools, many kind of platforms that have come up to solve these distributed platforms problems, distributed computing problems. One of them is a combination of Hadoop and Spark. That's the most popular combination. Second one is Cassandra. Cassandra is a database, as well as MongoDB is a database, but they are only good for handling velocity and sometimes data, but not the complexity, because the algorithms, the machine learning algorithms, are not really widely available at these platforms. So fourth one is the Google Compute Engine or AWS. These are hosted environment where you push your data to their places. These are not great for somebody who is having humongous data. The problem with Google Compute Engine or AWS is you will have to continuously pump the data from your your data systems to Amazon or Google. That's not preferable to many. All right. So we will talk about in this course, we'll talk about Hadoop, and these are the main components that we will focus our session. So before we jump into this slide looks a little scary. So do you have any question for me?
No, not for now.
All right.
Okay.
All right. Okay. So hi, Peter. I think you joined a little late. So Peter, Subi, Josephine, and Semambo, do you have any question for me?
So,
All right. Feel free to type the questions. I keep on looking at the chat box all the time, and okay. So keep the. I would love to answer your questions, no matter what kind of questions you have. I would love to answer those. Okay. Great. Great. All right. We have Abhinav from outside and Rohan as well. All right, so when we talk about big data platforms such as Hadoop and Spark, these are the most complete platforms. They provide end-to-end ecosystem of the components. The first one is the most and the fundamental one is the storage, the one that handles volume. That's called HDFS, Hadoop Distributed File System. Hadoop Distributed File System utilizes hundreds of computers or many computers to provide you a singular storage which is fault tolerant and highly available. So HDFS is that component. Next is, on top of HDFS, there are many other components. The next one is Yarn. Yarn is nothing but like a distributed operating system. Like an operating system executes a program on a computer, Yarn helps you running a program on the cluster. Okay, but since you really cannot use Yarn as such, you use Yarn by the way of the frameworks such as MapReduce and Spark. So you write your program for MapReduce or Spark and hand it over to Yarn to execute it. So we will talk about first HDFS, then Yarn, then MapReduce and Spark, and then we will talk about what does it mean by NoSQL databases, and then we'll talk about HBase. So HBase is a NoSQL database. It's a data store where you can store petabytes of data, petabytes of structured data, while in HDFS you store files. Here in HBase you store tables in the form of columns and rows. Okay, so in HBase you can have a table which has billions of columns and billions of rows, and it can handle that amount of storage. All right. So on top, once we understand these basic building blocks, we will talk about Hive. Since not everyone is great with coding, and not every problem is suitable to write code. Therefore, Hadoop guys have written something called Hive and Pig Latin, where you write your logic in the form of SQL or similar to SQL called Pig Latin, and then that gets converted into MapReduce and get executed in the Yarn. So that's something we'll study in detail. And then we will also learn a little bit about Mahout. where Mahat is a machine learning library. Okay, it's basically for a massive scale machine learning. Like you have to generate recommendations of movies, and there are millions and billions of people who have given the ratings. Based on that, you want to generate Mahat. My work at InMobi was in that I used Mahat, MapReduce, HBase, and HDFS. Okay, then once you have a project and you have coded in many of these components, you're going to stitch it in Uzi. All right. And as an end user, you can either talk via CLI, Java, Python, and so on. Also, if you have existing data, you would like to transfer that either using Flume or Scoop. Flume helps you push the data continuously into HDFS, and Scoop helps you push the data from structured data sources such as existing database. So these are the tools, plus there are a couple of more tools in Hadoop that we are going to discuss in this course. Next is the second big aspect in this course which we discuss is Spark. You will be wondering like how will we will be able to finish all these topics, and that's the reason why this course is of 42 hours. All right. In this section of the course, we'll talk about in detail about Spark architecture. And in this whole course, we have reduced the amount of time we are going to spend on Hadoop. Instead, we are going to spend more time on Spark. So Spark has many components. One is Spark Core. Then Spark Core is the main engine which runs on top of Yarn and other frameworks. And it can read the data from Hive, HBase, and HDFS. And on Spark, we will talk about how to do the fast processing using streaming, how to do complex processing of variety, the V for variety, on big data using MLlib and GraphX to process the social graph and other graphs. Then we will also talk about how to query the structured data, but structured data in humongous size using Spark SQL and data frames. And we largely will be using Scala instead of so many languages. Largely will be using Scala, but we'll give you one example each. We'll give you one example of each of these programming languages. So that's about the course. All right. So now question is, what is CloudxLab? Okay. So CloudxLab is, so that was about the two frameworks we have talked about. So far we have talked about what is big data, and then we have spent some time on understanding what are the components of Hadoop and what are the components which we are going to cover in Spark. Okay, before I jump to CloudxLab, I would love to answer your questions.
Let's go back to components of.
Okay.
So you say Dian is like some sort of operating system.
Right.
And then we have MapReduce, and
Right.
then Spark on top of that.
Right.
What's the difference between the main two, Spark and MapReduce?
All right. So in case of MapReduce, the output of one job goes into HDFS. While in case of Spark, the output is retained in the memory sometimes, and that's what makes it really fast. So if you have a complex problem would require many phases of MapReduces to solve it. Let's talk about generating recommendations. In generating recommendation, you will have to do lots of mathematics, as in the engine has to do a lot of MapReduces to compute to do various kinds of mathematical operation on a larger scale. So in a bigger problem, there are many phases of MapReduces, one after the another. And in case of MapReduce, this framework of MapReduce, the problem with those the chain of MapReduce chain of batches is the output of the first one goes into the second one, and so on. I would love to explain to you. This is something I would love. It's a great question, and so all right. Let me just pick up. Okay. So let's take a case of recommendation. In the recommendation engine, there'll be like let's imagine that there are many phases. Okay, so the output of one MapReduce framework goes into HDFS, then the next one reads it, then the output goes into HDFS, the next one reads it, and so on. Okay, so I'm trying to say that, let's say this side is, you will understand it as we talk about later. Okay, so there is, all right, one step back. Okay, the simple answer right now between MapReduce and Spark is exactly the competitor of MapReduce. Spark is competitor to MapReduce, and Spark is around 10 times and sometimes 100 times faster than the MapReduce. MapReduce was little older way of computation, while Spark is a newer way of computation. And here I'm trying to explain why Spark is faster than MapReduce. Okay, in MapReduce, every phase, these are first program, second program of MapReduce, they output to HDFS and read from HDFS. So there is a delay here. This delay is what it makes MapReduce program slow. So what they did was, instead of putting in HDFS, they started keeping it in Spark. They started keeping it in the memory or locally. So they have done the optimization between the various phases. So that's what is Spark. All right. Did it make sense to you?
Yeah.
All right. All right. Great. So, all right. So should I dig deep, or do you have more questions?
Okay, so in other words, what you're saying,
Mm-hmm.
for Spark, you would need more memory for it to be efficient.
Yeah. So if you want to optimize your jobs really well,
Yeah.
that bigger memory is welcome by Spark. Spark try to utilize around 70% of the memory. That ratio you can set up. Okay, so it basically tries to utilize the memory available. Okay, so yes, it might look like memory hungry, but it basically, if the memory is not available, it'll try to make use of whatever is available. So in other words, yes, Spark might be memory hungry.
Okay. All right.
All right, good, great, sir, great question. All right, so this diagram is clear. We have first layer is to store a lot of files. Then we have an operating system kind of model called Yarn, which can run any program in the network. Then on top of Yarn, we have MapReduce and Spark and others. Okay, yeah, on Yarn, you can run many kind of workloads. We call them workloads, or you can also call them frameworks. All right, and then you have next generation of I mean, higher level of computing involving SQL using Hive and Pig. Although Hive and Pig are being kind of replaced right now. I mean, at least Pig is being replaced and Mahout is being replaced because they have all moved to Spark. These tools, Mahout and Pig, used to run on MapReduce. So now they have been Moth is replaced with MLlib. Piglatin has been replaced with Spark SQL, and so is Hive. Okay, so that's the thing. And Spark is kind of easier to compute with. Therefore, in this course, we will spend a very less time on MapReduce, and we'll spend more time in Spark. We will spend more time into Spark than MapReduce.
Okay, what is the main form of interactivity with all these things? What are
Uh,
you, is it using any of the above programming languages? And just SQL?
I missed your question. Could you come
I'm
again?
asking, what is the main form of interactivity, running queries or programming on any of these platforms?
All right. All right. So, so the main, okay, so there are different use cases. One of the most popular way of using Spark is by the way of using Spark SQL. Okay. It provides you a very interactive way of talking to your data. Okay. Then the next form comes into play when you are interacting on this using a tool like R. So using R, you can interact with the Spark. The data scientists who are coming from R background, they are uh, readily moving onto Spark. They're very comfortable with Spark R. Now, the other form of computing on Spark is either submitting a job in the form of like full-fledged program that you submit to Spark, or you interact with the Spark in the form of the console, the interactive way, the way if you used Python earlier, you will see that you launch Python and then you keep on giving commands, it keeps on giving the answers. So that's a kind of interactivity that happens at Spark. Now, there could be two kind of work that you will do in the industry generally. One, where your program keeps on running 24/7. That's called unbounded data processing or stream processing. So that kind of work you would generally handle using streaming. Let us say you have to display the real-time analysis of the current orders being placed on your website. Let's say you are having a website whereby users are using your website and placing orders. Now, you want to observe, you want to display in real time. You want to display in real time how many orders are in the are in the processing phase, how many have been shipped, and how many are yet to receive the payment. Okay, so there could be, so if you have to display this data in a real time, you will have to do the stream processing. So that's one way. The other one is the batch wise processing. Let's say you have certain data and periodically you have to compute. Periodically you have to compute, let's say, most frequent words being used and so on, or let's say you have to frequently compute the sentiment analysis or recommendations, or you might have to compute to do certain other kind of processing, let's say fraud detection on the data periodically. So those kind of use cases are batch wise, while streaming use cases are where you have to continuously churn the data that's coming at a very fast pace. Okay, did I make sense to you?
Yeah, sure.
Okay, great set of questions. And all right, so this is what people generally use these frameworks for. And in case you are wondering, like, I'll show you. So CloudxLab./blog. Okay, so this is one good use case that we have. I mean, it's a real project which we have done for customer recently. So you may like to look at it. So it involves Spark, and wow, I'm not able to send to everyone. Good. Finally. Okay, so I have sent you the URL. You can take a look. This is a real use case of humongous data. We have done the processing using Spark. All right. Good. Good. Moving ahead. All right. Moving ahead. So now that was the learning part. The question is practicing part, because uh, these all frameworks, whatever you have, I've told you just now, I'm very sure all of these components are looking identical to you. You would be thinking, what's the difference between hive and pig? What's the difference between hive and HBase? What's the point of having, um, uh, say, yarn and MapReduce? So unless we do a hands-on, all of these components will look just bunch of words to you. Okay, that's why everything has to be done hands-on, and for that we have CloudxLab. So a brief idea about CloudxLab. So it's a 24/7 cloud-based lab for big data. Okay, so that our students can gain hands-on experience on big data technologies such as Hadoop and Spark and machine learning as well. Why did we do this? Why did we need this kind of expensive solution? Because there were problems with the existing solution. Earlier, before we started this, what everybody does in the industry was they were using virtual machines. And when I tried to help my students set up the virtual machine, I found that that's totally broken. Virtual machine, being huge in size, took long time to finish to download. Okay, to give you an idea, the Hortonworks virtual machine is around 10 gigabyte in size. Okay, to download 10 gigabyte, it takes at least 10 days because the download keeps breaking and there are many other problems. Next is installation is generally blocked on office computers for security reasons. And some of the BIOS, some of the hardwares do not allow virtual machines. On top of that, to run a virtual machine, people needed high-end computers of 8 gigabyte RAM. And if you don't have a 8 gigabyte computer, then you won't be able to use it. And that's not right thing. You needed lots of software installations. And to access virtual machine, the transferring file was very confusing and not like real life. So even though people tried virtual machine all the way and they were able to run it, they really did not learn distributed computing, because distributed computing by default requires many computers, right? So they did not really learn using a real world cluster, real world environment, and therefore learning on VM is incomplete. And moreover, we found that since data has to be transferred, next effort went in how to transfer data and download data from a source into the virtual machine. That became another problem. So at the end of it, there were too many support calls, bad experience for both instructors and students, and therefore we created CloudxLab so that people could practice anywhere, anytime, from any device, and some more. For example, we provide a good integration into LMS. We provide centralized data access so that all the students can use the data from a central source rather than having to upload, download, unzip, split, and so on, instead of transferring data. And since we talk about humongous data, transferring humongous data takes a lot of effort, patience, and time. So the centralized data access came as an added advantage to our lab. And the other added advantages that we got was it was easier to solve end users problem, because we could see that, let's say you are doing something, you wrote us an email saying, hey, I'm not able to do this. Let's say you are trying to run a Spark program, it did not run. what we will do is we will log in into your workspace and take a look at what exactly has gone wrong. And that's very important because that's where 90% of the users were stuck, because there was something or the other. They made mistake in their environment while the program ran successfully on my computers, but for them, because of difference in an environment, it became very difficult. Next is we have built something called automated hands-on assessments. For example, let's take a look at this. So I provide the steps that do these 5 steps, and once you are done, click on I am done, please check. And then our program goes into your workspace, check whether you have done things correctly, and then confirms it. If you are not, if it's you haven't done correctly, it will tell you that these are the things you have made wrong. So this way, the learning, even the subjective assignments or doing the project, became very automatically tested. That way, the new learners got somebody to help them instantaneously with their assignment, with their work, whether they are doing things right or wrong. So this we have built for our students, and people are using and finding it very engaging and very interesting, because what happens is lots of people have the hesitation of not sharing their work with the instructor, thinking that because of the shame that, oh, what would the instructor say, and so on. And that's a very common problem. So because of automated hands-on assessments, the whole process of learning has become very engaging, instant, because it's instantaneous evaluation. All right. And the next question you might ask is, what is it that we can practice? We can practice on CloudxLab. So these are the tools. These tools largely comprises of Hadoop ecosystem, Spark ecosystem, NoSQLs, data analytics tools, and machine learning and deep learning tools. Okay, so since these days lots of wonderful platform for machine learning have come up, so we have made those platforms, those tools and libraries available to our students. Other than Hadoop, Spark, Kafka, Hive, Pig, HBase, Zookeeper, Oozie, Flume, Scoop, Mahout, MongoDB, NumPy, SciPy, and Scikit-learn, and R. These are machine learning libraries, along with Pandas. These 1, 2, 3, 4, 5, 6. These 6 libraries, no, 7 libraries, are for machine learning and deep learning. And we have Python. These are the basic tools like Python, Linux, Java, and C compiler. All right. Other than these tools, you have all kinds of source code compilation and checkout tools like Git, SVN, and others. All right. So all of these tools are made available to our students so that they do not face any kind of hesitation in trying out various things. All right. And our clientele includes Simplilearn. Simplilearn is a big e-learning company. Insofe is a very big analytics company. And SCMHRD is a management college. Nationwide is a global chain of hospitals. ITC Infotech is again information technology giant. Then we have instructors from Udemy, Apex, IBM, and Common Floor, and Transneuron. And along with that, we have Dell and Emphasis using our platform. So there are there are many people who are using our lab in order to upskill and train their employees along with the individuals. So there have been more than 5,000 users who have learned and practiced with us on CloudxLab. Now, these are the basic interfaces. One is Ambari, where you can see what's going on at on the admin level. Then you have Hue, whereby you can upload, download data, and we have Web Console. And we also have uh, the other interfaces for various kinds of tools. For example, for iBook, we are using one particular tool. I have forgotten its name. So that's also being used here on the in the lab. All right, so this is the console because we realized that installing a software to connect to the lab for the command prompt was difficult. So we built it into the browser. So you don't have to install anything. So the whole process have become zero installation. All right. Then we have good integrations with LMS. This is the example LMS of No Big Data, where we have all the details about the course along with videos and content. At the top of it, people would see their login and password for the CloudxLab. Okay. All right. So that was about CloudxLab. I have moved a little faster, so I'm sure you will have a lot of questions. Yes.
Mhm. So it looks like most of these big data technologies
Mhm.
predominantly run on Unix, Linux platforms. Is that the case? Do we have anything running on Windows?
Yes and no. Almost all of these tools, because these are designed for server side, most of these tools have been built for Unix and Linux. But since Hadoop runs on Java, it was possible to port that Hadoop into Azure. That's called HD Insights. So HD Insights is Microsoft's port to Windows. So Hadoop does run on Windows, but that's not much preferable because on the server side, till date, people's preferred choice has been Linux systems or Unix systems, but it can very well run on Windows if you are using basically same Hadoop, just that it has been bundled for Windows called HD Insights. So if you use HD Insights, you can use that. All right. Spark also runs very well on Windows. You can download Spark on Windows and it works fine. All right. But since the way we visualize is that since in industry, the main challenge most of the candidates faced was regarding, let's say, getting upskilled on a client project. There they realized that, okay, the whole environment is Unix. So it's better to upskill people on Unix than on Windows. So that's the reason why we have chosen this one as compared to HD Insights. We do have plans to launch a cluster on HD Insights, but that will happen after probably 3 to 4 months. We are in talks with Microsoft.
Okay. So Jan,
Yeah.
sometimes you say Hadoop and Spark, I get some sort of confusion. Can you run Spark without Yarn or anything?
Yes, very good question. Very good question. So Spark, as you see in this diagram, it can run on Yarn. It can run on Amazon EC2. It can run standalone. It comes with its own manager. Yarn is nothing but resource manager of the network. So Spark comes with its own resource manager. So Spark can actually run without any resource manager. Along with that, there is another competitor to Yarn called Apache Mesos. So Spark can run on that as well. But Spark does not provide storage as compared to Hadoop. Here in Hadoop, Hadoop provides Yarn, HDFS, and HBase, and then MapReduce. So rest of the tools are around these three basic things.
Okay.
Okay, so if you say Hadoop, Hadoop is nothing but Hadoop equals HDFS plus HBase plus Yarn plus MapReduce. Now MapReduce is being replaced with the Spark. That's all.
Okay. So would Spark be able also to do what MapReduce can do as well?
Yes. Almost every problem that can be solved with
Mhm.
Hadoop, Hadoop's MapReduce can be solved with Spark.
Okay. So are we saying in future we probably Spark will be more dominant?
Yes.
Okay. Right.
Because what I'm seeing is if you see the development
Mhm.
of libraries is happening at a very fast pace. I'll give you a good example. So the researcher who built Mahout, okay, is
Yeah.
now moving Mahout entirely to Spark.
Ah.
Okay, so I mean, I can see that movement at a very fast pace. So I'm in touch with these people who are building these tools. So to me, it looks very obvious that MapReduce is going to get replaced because Hortonworks and Cloudera both have accepted Spark, and they are not really trying to push MapReduce. So that's the reason. So that's why we have also trimmed down our classes. Generally, we used to run 4 classes on MapReduce, how to solve a problem using MapReduce. And instead of that, we have made it like half class. And the rest of the time, we devote to Spark,
Okay.
all right? Because we would like to keep the people, we would like to train people into something which is going to be the future. But HDFS, HBase, and Yarn are going to stay, and people are going to use those. There's no better solution than these 3 components: this,
Mhm.
this, and this, as as of now.
Oh, but for the HBase, the no SQL data store,
Right.
are we able to replace that with things like MongoDB or anything?
Uh, the Yes. So with MongoDB is it's the use case is different. With MongoDB, the use case is different, but HBase has got its own use case. So we'll talk about differences between the various NoSQL solutions and when to use which one. All right. The good
Okay.
part about Yarn is that it's able to now HBase runs on top of Yarn and uses HDFS to store its files because internally the tables get converted into files and those are stored in HDFS. Similarly, other databases, say Cassandra, is also moving on to Yarn and HDFS. So essentially, things will run on top of these two.
Uh, is HBase, is it document oriented as well? Just like,
It's not. It's mostly column oriented, or we call that column family oriented.
oh, okay.
We will go into the details about NoSQL, like what's the use of this kind of architecture, and how
Mhm.
to do the data modeling for HBase.
All right.
All right,
Okay. Yeah. I think
great,
that's about,
great questions, wonderful
yeah.
questions.
Yeah.
All right, any other questions?
There's some questions coming through on the chat. I wonder if you're able to read them.
Oh, nice. I did not see that. All right. Peter's question is, what kind of infrastructure, hardware capacity do most use cases, say bank, telecoms have in place? I mean, number of servers, storage, capacity processing, etc. Is it safe to zero down on Java as a language? It's being multi-platform. Okay, wonderful question. Let me answer one at a time. All right, let me note it down so that we can all see what I'm talking about. Okay. All right. So first question. The question is what kind of storage, what kind of number of servers and storage capacity, what kind of machines people are using. All right. So there are generally two extremes of the computing. One is distributed and other is parallel. The people who like parallel computing, they generally go for supercomputers, And the other end, where they want to really churn a lot of data, they basically have and they basically go for distributed, because when you have a lot of data, it doesn't make any sense to go for the parallel computing environment. Okay, now coming back to what kind of servers, and I'll give you an example of InMobi. Okay, at InMobi, we had a humongous data store. So we were using around 800 nodes. We were having 800 nodes, and mostly commodity hardware. Commodity hardware. Okay, commodity hardware means although high quality hardware, but the RAM was say 16 GB or 32 GB, 16 or 32 GB of RAM, and my hard disk was like on every machine we kept 1 TB and so on. Okay, so we were talking, although out of these 800 nodes, four earlier nodes, the one which we built in 2010, were actually pretty low end, 4 GB and 8 GB or that kind of nodes. So, the 800 nodes have had accumulated over a period of time. So we started with say 8 computers sitting in our rack, then we took the hardware, moved it to a data center, and then we realized that it's costing us a little higher. Then we set it up in a professional AWS manner, and so on. So we basically started in our own data center, and then we some part of it we moved to AWS, some part of it we kept at home. So we had different solutions for different kind of problems. And at DShaw, the kind of nodes we had was 10,000 nodes, and so on. Now, coming back to banks and telecoms, I believe that they'll be having more than 100 nodes cluster. Okay, because here the idea is not to buy really high-end computers, but decent kind of nodes, decent um, capacity nodes, and connect them, because the idea of distributed computing is to be able to utilize the processing memory and the read speed of the disk in a distributed fashion. So even if you have a small computer, you will be able to utilize these three attributes of each node. All right. So this is the statistics which I have upfront available. And this one, rest, I'm not sure about the other banks, but everybody would have built a similar kind of capacity. All right. Did that answer your question, Peter?
Yes, it does. Yeah.
Okay. Okay. Great. Great question. Now, second question is it safe to zero down on Java as a language, it being platform? Okay, that's a very good question. And this I get asked quite often. All right. So yes, all of these components, whether Hadoop, HBase, Yarn, let's not write this Hadoop, let's call it HDFS. Okay, all of these components are written in Java. And to your surprise, the Spark, which is written in Scala, is actually Java, because Scala also compiles to Java. All right, so here is my hypothesis. My hypothesis is that even though Java will remain kind of a platform, but other languages that can run on top of Java will evolve and come into play. One of the examples is Scala. All right, and sometimes we use the third kind of libraries, say Python. And Python is, so on one end, we have interoperability so that our program can run everywhere. On the other hand, we have the user friendliness, because data scientists are more comfortable with Python and R than, than, than Java. Therefore, users will be using Scala, Python, or R, while the platform will run on Java. Okay, so this is what I foresee. So the language of choice will keep on changing with the developers, with the kind of use case we have, while the infra, most of these tools will run on Java. Do I make sense to you, Peter?
Yeah.
All right. So, and the reason why we have, earlier we were running the course in Python, but then we have moved to Scala because one, Scala when it's compiled, it can run on Java virtual machine. Second, Scala is in high demand. It's quite easier to code because when you are having a lot of data, most of the data scientists want a language with which they can quickly code and test the hypothesis, compare the results, and clean the data. For that, Python was a great solution, but Scala is even better because Scala also is faster than the normal code we write in Java. So Scala is compatible with Java, faster than Java, and uh, and actually uh, and actually easier to code. So that's the reason why we have moved to Scala, right? And and as opposed to my first Hadoop program was actually written in Python. Entire flow of MapReduce I had written in Python, and the reason was that it was easier to code because I had to experiment with a lot of data. So I found that Python to be quite useful, and now I'm finding the same amount of performance and efficiency on Scala. All right, great set of question. All right, did I make sense to you all? Samambo, Josephine, Peter, Rohan, Abhinav.
Yeah.
Okay, another question is, in typical use case, where would the cloud platform fit in, specifically for the areas like Uganda, where internet connectivity is not so good? All right, so do you mean the CloudxLab or do you mean the big data cloud platform?
Big data cloud platform.
Right. So mostly these platforms do not interface to the customer or the consumer. These platforms remain as the backend. These platforms are the places where you accumulate the entire data, structure the entire data, or sometimes your web servers, which are gathering a lot of data, they store data into, say, HBase. But generally, you do not show these, you do not expose these frameworks to the end user. So end user, connectivity with the end user is not really much of a concern for the big data platform, while the connectivity amongst these computers is very important. Let's say you have 800 nodes. Connectivity between them is kind of uh, very much possible because you have to internally connect them. So, and that is irrelevant of whether you are in Uganda or elsewhere, and that because that's independent of the internet connectivity. The only problem you'll face is the backup side. So generally what people do is they set up the big data platform as a partitioned network. Some of the machines would be at a remote location, say in United States, some of the machines will be in Africa, and the backup of the machines will keep happening even when the connection is flaky. Most of these tools are designed in a way that they have a good replication factor, whether it's uh, MongoDB, Cassandra, HBase, HDFS, all of these tools have a great amount of resilience in terms of if one machine goes down, the other one will take over and so on. So even if the connectivity is flaky between the backup machines and the main cluster, still these platforms do perform very well. Okay, did I answer your question?
Yes, yes, yes.
Right. Great.
Hi everyone, this is Rohan here.
Hey, Rohan. Yeah.
Sandeep, anything else or can we?
Yeah, I'm kind of done. I'm just waiting for more questions.
Okay. So I just a quick summary. I mean, though not on the course as such, but I think this was meant to be a primer, like an introduction to the entire course that Sandeep gives out. I mean, through No Big Data. So I think if it was helpful, I mean, it would be great to kind of give us your feedback either now or later. But you have seen, right, how this is a more interactive way of learning, where one, there is someone with credibility like Sandeep, who's done real world big data problems and solved it at a level at AWS, in Mobi, some of the companies that are known to handle big data problems very well. And he's architected most of these solutions himself. So, and that is one part. And the other part is CloudxLab, which is really sets us apart from any other training, where post training you really have a platform to go ahead and practice and better your big data skills. So hopefully you guys have kind of gotten a lot of intro into what the training can offer, what the full-fledged training can offer. So if there's no further questions, we'll wrap it up and wait for your feedback. Sounds good.
Okay. Uh, All right. Simambo, Josephine, Peter, any more questions? And
Yes. Can you hear me?
yeah, I can hear you. Yeah.
Yeah. What are the prerequisites for the course?
Prerequisites are somebody with little hands-on experience with SQL and basics of Unix and some amount of computing, just basics of computing. Say you, even if somebody has done a programming 10 years back, that's good. But most of the things that we cover, be it SQL, be it Linux, be it the programming language called Scala, we will cover in the course itself. We will teach Scala as part of this course.
Okay.
Okay. So we'll dedicate enough time on Scala so that, and the exercises will be hands-on, as in everybody will log in with me simultaneously, and we will work together on whatever exercises are there on Scala, so that everybody gets comfortable on the language side. And SQL as well. All of the way we learn in this course is that everybody will be doing exercises together with me instead of just listening. This is the only session where I am talking and there are no hands-on.
Okay.
Okay.
All right. Thank you.
All right. So that's about it. Good question. Any? All right. So that's pretty much. Do you have any more question?
One more question.
Yes, please.
Where I don't know if it makes sense actually. Where does the warehousing fit in all this data?
Come again, please.
The question is,
Mm-hmm.
where does data warehousing fit in all this big data?
Good question. Good question. So basically, the most of the data is actually being moved from a typical data warehouse into these environments. Okay. So it's kind of improving the existing data warehouse. And yeah, so if you look at it, the way we store data in a data warehouse, in the same way, here these solutions like HDFS, Hive, HBase, they are for the data for basically storing data for the processing. That's what exactly the data warehousing was supposed to do. Okay, so it's kind of improved data warehousing or for humongous data.
Okay.
Okay.
Okay. I
Great
think that's
question.
it.
Great question. Yeah. All right. I look forward for your feedback, and feel free to reach us at No Big Data at any point of time. All right. So, all right. Thank you, everyone. It was a wonderful session, wonderful set of questions. I thoroughly enjoyed it. Okay. Thank you. Bye, Rohan. Bye, Peter. Bye, Josephine. Bye, Imam.
Isn't it?
Bye.
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 Cindy.